Assalamualaikum dan salam sejahtera to all students. So today we're going to learn chapter 3, wave. This week's I will going to cover from 3.1 to 3.3 contents only. For 3.4 until 3.7 we'll cover by next week's. Characteristic of wave is a pulse caused by a disturbance in a medium. As you can see in the figure, so the force applied here, the cohesive force between adjacent part cause the adjacent part cause the wave. When the disturbance continuous and oscillating or continuous or periodic wave is produced. So from the figure here, there are two parameters we can obtain. First one is amplitude. Amplitude is the maximum height. Okay, all these are amplitudes. And this is known as a crest or peak, and this one known as a throw. So as you can see here, when two successive parts meet, which is known as crest to crest, so we can measure a lambda wavelength, or we can measure by using a throw. Throw meet with throw, so we can measure a lambda. It's whether you want to measure the lambda from crest point to crest point or from the throw point to throw point. It depends on you. Let's proceed with important parameter you should know in this wave, in this subtopic. First one is amplitude. As I mentioned earlier, is the maximum height of a crest or depth of a throw relative to the normal. So the unit is normally cm or meter. So the wavelength is the distance between two successive identical points on the wave. For example, distance between two successive crests. The unit is centimeter or meter. It depends on the question given. Frequency F is the number of complete cycle per unit time. The unit is a hertz or per second. Period T is the time required for one complete oscillation. T equal to 1 over F. So the unit is second. Wave velocity, the velocity at which any part of the wave, or for example, crest move. V equal to F lambda. So the unit is meter per second. Proceed with important parameter you should know. So again, for velocity, speed of wave on chord. Chord is normally related to the tension. The speed of wave having the same amplitude on a string or chord. So as you can see here, equal to square root of Ft divided by mass per length. So mass in kg, F in Newton, length in meter. So now let's see at the graphical representation. So there are two types of graph in this chapter for wave. First one is displacement versus distance graph. From the graph here, we can obtain three parameters. First one is displacement y. As you can see, displacement versus distance. So y, and amplitude is a. How to find the amplitude? So we take the maximum height here. Wavelength, as I mentioned earlier, from the crest to crest, or from the throw to throw, or one complete oscillation. For example, okay, as you can see here, if let's say you start at here at 0, so if let's say you start here, so then from this point and end here, so we can find the wavelength here. Or either you can use this part to this part. Also, we can find a lambda here. Okay, this is amplitude. Above, upper or below, it depends on you which one you want to take, as long as you know. Displacement. Second one is displacement versus time graph. So from this graph we can obtain a amplitude. Okay, same goes here. Is maximum height. The period is the one time taken for one complete oscillation. So here starting point and complete oscillation is stop at here. Alright, similar to wavelength. So then This is the period. We can find the period. Or you also can measure from throw to throw or from the crest to crest. So we will get period too. It depends which one you want to measure. So remember for the period, make sure the graph is displacement versus with the time. Example. Determine the amplitude and wavelength of the wave. As you can see, the first graph. First graph shows the graph displacement versus distance. Alright, so the amplitude, how to find the amplitude? Amplitude is maximum height. Height here is 20. So the amplitude equal to 20 centimeter. How about wavelength? So how to find the wavelength? So as I mentioned, you can take a point from throw to throw. Or you can take from the starting point here and stop at one complete oscillation. Let's see what is the value. 0, 15, so the gap difference is 15, 20, 30, 45 and 60. So the wavelength is 60 centimeter. Agree class? Clear? Or let's check by using a pick point or throw point. So here 15, here is 75 centimeter. So the distance here is 75 minus with 15. So we got is the value is 60 cm. So the wavelength is 60 cm. Let's proceed with the second example. Determine the amplitude and period of the wave. As you can see here, the graph represents y versus t, displacement versus time. So amplitude same, which is a 20 centimeter because the height maximum is 20 centimeter. How about period? One complete oscillation. The starting point here is here and stop at. What do you think? What is the value here? 5, 10. So the gap is 5. The increment is by 5. 5, 10, 15 and 20 centimeter. So the period is 20 seconds. Agree class? Alright. Make sure if you don't understand, make sure you listen again and again. Type of wave. There are two types of wave. For this one, two things you need to consider. First one is the definition of wave. The second one is the is the example of wave. Transverse wave is the motion of the wave particle are perpendicular or transverse to the propagation of the wave. For example, wave on the water, on cord, on land, as you can see in the figure. Longitudinal wave is the wave motion of the wave particle is the parallel to the propagation of the wave. As you can see in the figure, it's parallel. So for example, sound wave. As you can see, example there. Next one, mathematical representation of a wave. For this one, consider a one-dimensional wave traveling along the x-axis. As you can see in the figure, there are d versus x. Right, d versus x. Okay, this is along the wave traveling at t equal to 0. At t equal to 0 here, okay, yx 0. 0 means that t equal to 0. Right, so a sine 2 pi divided by lambda x. 2 pi divided by lambda is represent the constant. Constant in simple harmonic motion, which is equal to k x. K. Sinusoidal wave moving in the positive x direction. Right, so let's see at the equation here. Suppose the wave moves to the right. As you can see, it moves to the right at velocity v. At t second letter, at the time equal to t second letter. Okay, so then a sine 2 pi divided by lambda x minus v. t, x minus with t, because of the wave here traveling with x divided by vt. Vt is the distance traveled by the wave. And simplify the equation here. We know that v equal to f lambda. Substitute the f lambda in here. So then simplify the equation. We got the t. Summarize the 2 pi here. Then we got the x divided by lambda. T divided by the t, capital letter of t represent the period. Then y, simplify again by substitute the equation omega equal to 2 pi f. Then we got the equation, general equation of the wave travel, which equal to a sine kx minus omega t. K is the wave number and omega is the angular frequency. Kx minus omega t represent the pace.